Welcome to the fifth section on carbohydrates. This section is covering sugar. We're going to start by taking a look at added sugar and how you can identify added sugar when you're looking at a product. Now remember, anytime you are eating added sugar, you're eating a processed and refined foods, and I've been drilling into your head this semester that you really want to focus on whole foods. But we live in the real world, and sometimes we all will grab for some processed or packaged foods. So when you look at the ingredient label, some key terms can alert you to if there's added sugar in the product. Anything that ends with OSE, that OS, so remember lactose, glucose, lactose, maltose, sucrose, dextrose, so those are all the sugars we learned about. With the exception of dextrose, that's another one. But if you don't recognize the first part of it, if it's not glucose or fructose or sugar you recognize, you can just look for the OSE. So that's a sign of added sugar. Anything that says syrup on it, it doesn't matter if it starts with organic, if it ends with syrup, it is an added sugar. Maple syrup is an added sugar. So anything with syrup at the end of it. Anything that says sweetener, any sort of sweeteners are going to be added sugars, and you have to be careful with concentrated juices. If there's a concentrated juice added to a packaged product sitting on a shelf, it's going to be all added sugar. There's most of the nutrient value is gone. Some concentrated juices just remove the water, so you really have to be careful. So concentrated juice, this should alert you in a packaged product that is added sugar. Cane sugar, corn sugar, and we can make gain sugar or obtain sugar from sugar cane or from corn, and we'll talk about how that is made. Dextrose, just as I mentioned before, anything with an OSE should alert you to an added sugar. Brown sugar, this is just white sugar really with the molasses not removed from it. Honey is an added sugar. I'm just going to take a moment to distinguish honey because it is one of our only naturally occurring sources of sugar that doesn't come in a fruit or vegetable. Before the last 100 or 200 years, it was a rarity, so it wasn't used in abundance. Now you can get it in a plastic squeeze bottle at the store. When you buy it at the store, it is most likely highly refined. There are no nutrients or enzymes or anything of nutritional value in there. If you are buying raw organic honey at the local farmer's market, then you probably are gaining a little bit of nutritional value from that. But keep in mind, it's still a very concentrated form of sugar. I can't argue that that wouldn't be a better source of sugar if you're going to use sugar, but it still needs to be less than 5% of your total calories. Fructose, remember that was our fruit sugar, but if you take it out of the fruit and you put it in a packaged product, it is not good for you. It is just sugar. So it has none of those, the nutrients or the fiber or phytochemicals. So fructose in a product is just sugar. Sucrose, this is table sugar, high fructose corn syrup, which we'll talk about in a minute, and corn syrup. So the little bit of difference between these two is that high fructose corn syrup made from corn has a little bit more fructose than regular corn syrup. Brown rice syrup, it sounds good for you, is still a syrup. Anything that ends with syrup means that they have extracted whatever sugar in that product and then added it to a refined product. Brown rice sugar is not as sweet, so some people find it to be a better sweetener to use, but people generally use more because it's not as sweet. Agave sugar, this is definitely one of the new sugars on the market. Still, as soon as you extract a sugar from any sort of plant and you put it into a packaged product, again, this doesn't make it good for you. It's still not good for you. Dehydrated cane juice, and you can put organic in front of that. It's still dehydrated cane juice, which is really cane sugar. And then maltodextrin. Maltodextrin isn't really a sugar, but it's like a small starch. It's basically a bunch of glucose linked together. It actually digests faster than most of these, more quickly, and raises your blood sugar more quickly. But you'll see maltodextrin added to a lot of products. So this is cane sugar, and this is where we get most of our table sugar. This and from beets. So there's beet sugar, cane sugar, but a lot of it does come from sugar cane. So that table sugar, the white granulated sugar. I'm going to go through some pictures or some processes, and this is going to be a little old school, but it's the only picture, open source picture I could find. But essentially, if you put sugar cane into a press, you're going to squeeze out the juice. And this is, it now happens on a very large scale, but that's how you're getting that sugar out of the cane, is by taking out the fibrous area here and then getting to pressing out the sugar juice. So this is cane juice, and that's really one of the first steps. Then the water is evaporated, and this leaves these brown crystals. This is evaporated cane juice, so this is another step in the process. There's generally a little bit of molasses left on here, and that's saved and used for molasses, and then some of that, sometimes that'll be added back in for brown sugar. Some of the, usually a very raw type of sugar where there might still be bugs in it or other particles or dirt, that's all cleaned out. So true raw sugar is not sold in the United States because it does have to go through some refining process to remove things that could be dangerous or bad to our health. And I say that as if sugar is good for our health, but when you see raw sugar on a package, it's not truly a raw sugar. Then there is a clarifying process where phosphoric acid and calcium hydroxide are added, and they form a precipitate, and it takes out those impurities, and it makes the brown sugar, those brown crystals, into the white granulated sugar. So that's the most refined sugar. So it's the most pure. When they talk about a pure sugar, they have isolated just the sucrose from the sugar cane to be sold. And so it goes through these processing. I've abbreviated these processing steps. But the reason I want to bring this up is because many times we get fooled by, oh, I'm getting evaporated cane juice instead of white sugar. Well, this is true. You are eliminating, the clarifying step or one of the processing steps, but at the same time you're still getting all of the sucrose. So all of the sugar is still in there. Even though it might be just a tad bit better for you, I don't want you to think of it as a healthy option or a healthy choice. Well, I was watching a TED Talk with Christina Werner, and she was talking about ancestral diets, and she asked this question, and I thought it was a great question. How much sugar cane would you have to eat to consume enough sugar to equal a 34-ounce Coca-Cola? So a 34-ounce Coca-Cola, it's actually not, the big gulps, the big ones are the 64 usually. So if you were to kind of shrink that down to almost about half, which you can consume in 5, maybe 10 minutes if you're slowly slurping away. How much sugar cane would you actually have to eat to consume enough to equal this? 8.5 feet. 8.5 feet of this sugar cane. And the way, if people were going to consume that, they used to stick it in and just gnaw on the outside and try to suck some of that sugar out. I don't know how long that would take. I've never tried this. I imagine days or weeks, but I think it's a fantastic point because, as we just talked about in the last lecture, when you are consuming sugar in high doses, it gets digested quickly. It is absorbed quickly. It skyrockets your blood glucose levels, right? It also insults your liver, and then we have that insulin response, and you get the sugar high and the sugar low. If you were to eat just the sugar cane, how you would have such a small amount of sugar just gradually going into your bloodstream. You're just not going to have the same impact on your system, on your blood glucose levels, or on your liver. So this just is a table looking at the empty calories in sugar and a little bit of a comparison between the different types of added sugar. We're going to start with table sugar. So this is sucrose, and this is cane sugar. The calories are 46, and notice that honey, which is a little bit more dense, has more calories and basically more sugar in it if we're looking at tablespoons for 1 tablespoon. But look at just our table sugar. There's nothing of any value in here for us, right? If we go down to honey, there's certainly no protein or fiber in any of these. We can see it has a little bit of calcium and iron, potassium, and that is one of the big arguments for using honey, is that it does have some nutrients. It has a lot fewer of these in a really highly refined honey in a plastic squeeze bottle, and probably a little bit more in, say, a raw organic honey you might find in a local farmer's market. But if we looked at it in comparison to what we need in a day, you can see that it would take a lot of honey to get us to the amount of nutrients we need in a day. And these are our daily values, but if we look at what would constitute a good source of a nutrient, remember that is over 10% of your daily value. So if you can obtain 10% of your daily value for, say, calcium, then that would be considered a good source. You need 1,000 milligrams of calcium a day, or most people do. So you would need 100 milligrams to make it a good source. And you have 1 milligram in honey. So you'd only need to eat 100 tablespoons of honey to even get a good source of calcium. And even if we look at iron, for a woman you need about 0.8 milligrams in order to make it a good source, and we're only at 0.1, so really, really small amount. And it's similar, you can see it's just a little bit higher in brown sugar, certainly not getting to any of the ranges that even get close to a good source. And remember that for something to be a high in a specific nutrient, it should be 20% of your daily value or more. But I do want to point to molasses, because it is interesting that molasses actually does meet some of these guidelines. Look, it does have 1 milligram of iron, so you can get iron from molasses. This does make it a good source also of magnesium. Molasses is not that sweet, so although it could be a good substitute for a sweetener, because you will be getting a little bit of nutrients. Again, a lot of people end up adding more if they are using it, just because you're still trying to gain that sweetness. So I've been talking about naturally occurring sources versus added sources of sugar, and if they're all the same thing, what difference does it make? Well, when you take a sugar out of a fruit or out of a vegetable and you put it into a processed food, it makes no difference at all. It really doesn't. It doesn't matter if it was derived in a lab or they pulled it out of a piece of fruit. It doesn't matter. Or synthesized in the lab. What matters is the package it comes in. So when we talk about naturally occurring sugars, these occur in fruits and vegetables and milk. So let's take a look. Fructose, remember this is our fruit sugar. It occurs most commonly in fruit in the highest amount, and it occurs in fruits and vegetables. It also occurs in vegetables. This is surrounded by fiber. Remember I mentioned before that sugar always occurs with fiber in nature, with that small exception of honey. Sugar occurs with fiber in nature. And I'm going to explain in a minute why that's important. Also, micronutrients and phytonutrients. Another naturally occurring source is lactose. So lactose comes in milk. It's also in breast milk, and we'll talk about this later. It's very easily digested by infants. Lactose is a naturally occurring source of sugar. It's not very sweet, so you don't see that pulled out of milk and then put into products. And then we do have some glucose and sucrose. Remember, sucrose is like table sugar. These also occur in fruit, just to a smaller extent. So this is very different. When you are consuming these products, you are also getting other nutrients along with them. In milk, there's also fat in there, which does help slow absorption of glucose. There's also protein, riboflavin. Generally, vitamin A and D are added to milk because they're not naturally occurring. But there are other things that occur with milk as opposed to just the sugar. So added sugar, we just went through these, but when you look on the package, you'll see the sugar, high fructose corn syrup, other corn syrups, fructose and honey. And again, when fructose and honey are added to products, they are added sugars. And I know I've said this a bunch of times, but I'm going to drill it in. It's about the package it comes in. When sugar is surrounded by nutrients, when it's surrounded by fiber, it's going to slow that absorption of glucose, and you're getting other nutrients in the process. When you take it out and concentrate it and put it into a packaged product, you get much more sugar. For starters, a tremendous amount more sugar, but there's also not a lot of nutrients that go along with it. So I'm going to talk a little bit about what can happen to fiber in foods when it's processed. And again, this is when we think about a whole food, it has micronutrients, so that's your vitamins and minerals. It has phytonutrients, and we talked about that. They have a lot of actions, but mainly as antioxidants. They help prevent chronic disease, and fiber. So when you eat the whole package, you're getting everything. Fiber is mainly, one of its main functions is to slow the absorption of glucose. And remember, I had talked about how the differences between soluble and insoluble fiber. But we think of soluble fiber as slowing the absorption of glucose, but it's actually the two work together. Both soluble and insoluble work together. And when you have a refined product, and I want you to think about your favorite bread, and I want you to think about how light and how fluffy it is, and it's chewy. You don't see any kernels in there. It's not bitter. It's not crunchy. It doesn't fall apart. That's a very highly refined product. It's highly processed, and it might actually have, say, 3 grams of fiber per serving. And remember that when you're looking for food sources, you want to look for a good source, which would mean more than 2.5 grams of fiber per serving. And that's a general rule when selecting bread. But here's the problem with breads. A lot of times they may take their whole grains and they pulverize them. So we think about our blender pulverizing something, but they have a high-speed blender. It's going to take that, something that's a kernel, and make it into a fine powder. Think of, cumin or cinnamon or something like that, that really fine powder. And still add it to the product. So it's going to give you that kind of light, fluffy characteristic, that fiber. The fiber's still in there, but it's not going to do its job. And here's why. I have this picture back here because it shows a lattice. And if you think about the absorption of glucose being slowed down by basically a drain on, think about the drain on your tub. And I'm going to take this from Dr. Lustig. This is his analogy. There's a drain on your tub, and when you use the drain, it will slow the amount of water that leaves the tub. That's the insoluble fiber, this lattice. Remember, it's more structural. The soluble fiber, think about this as the soluble fiber being the hair, maybe the soapy, the sudsiness, the gel that's kind of sticks to there. So what does that do? That kind of plugs up everything. You ever gone back and the tub is, it's still half full because it's taking so long to drain? Well, think about those two things working together to slow the absorption of glucose into the bloodstream. And they have to work together. So it's that trapping of the soluble fiber tends to be more of the trap, and then the insoluble fiber is the lattice. Now, if you pulverize the fiber, if you take the fiber and make it into a thin powder, you will still have fiber in your product. And it might still be in the same exact proportion that it was in as a whole grain. But now, there are a bunch of holes in it. And this is what happens. You just have your little segments of your fiber. And you don't have, now you don't have anything that the hair and that soapy gel can really catch on to. So the insoluble and soluble fiber can't work together as well. What happens now? Well, it might slow the absorption a little bit, but it really doesn't as much. So to demonstrate this, if you don't have your intact fiber, if you pulverize it, you make it into a fine powder, what happens? The tub empties quickly. Say from a whole food, such as a vegetable, the absorption of glucose is going to be much slower. We can have both a soluble and insoluble fiber working together to slow that glucose from absorbing into the bloodstream. So it's more in a steady state. It's just like the drain in the tub and the water. The water is going to come out much more slowly if you have the drain in place and working together with the gel and the hair. So that's a good analogy to compare to your absorption of glucose. So lastly, we're going to take a look at corn syrup and high fructose corn syrup. This is, remember we talked about our starch, just a chain of glucose. They're all linked together, packed tightly together. This represents our starch. So in this instance, where do we get the starch from? From corn. So corn is a very starchy vegetable. So what they do in order to make corn syrup or corn sugar is break it down just as we would in the body. So you're going to break it down into maltose and then into glucose. So when you get a corn sugar, it's going to be similar to maltose, and then that can break down into glucose. But for high fructose corn syrup, they do another step. So you go from starch to maltose to the 2-glucose, and then there's a chemical reaction in the lab, and that changes the glucose into fructose, and then bumps it up to about 55%, whereas glucose is 40%. And then there's a mix of other sugars in there as well. So if you compare it to table sugar, you have 50% glucose and 50% fructose. With this one, you're going to have 40 or 45% glucose to 55% fructose. So it still is a higher fructose level, but it's not dramatically higher. So there is a problem with high fructose corn syrup. It has been causing problems. It is for a number of reasons, but one of the key reasons is that it is added to all processed foods. And we're now in a process where they're taking it out of foods and they're substituting it for other sugars like corn syrup or sucrose or corn sugar or cane sugar, something like that. So it's not necessarily that much better to have those other sugars. If you're still eating those processed products, even though they don't have high fructose corn syrup, they're not necessarily good for you. In fact, they're definitely not good for you. They're not necessarily better for you. There are some arguments that because of this extra fructose in here, this little bit more fructose, that it is getting a higher dose of fructose to the liver. And once that impacts the liver, it does contribute to higher levels of uric acid, also insulin resistance within the liver. So there are some health problems linked directly to that. But if people weren't eating refined or processed foods anyway, they wouldn't be getting any of that the glucose or fructose from any of the refined sugars. So although I do think high fructose corn syrup is a problem, I don't think it's the target or should be the target. It's the products that it comes in that are the problem. And that's the reason that you want to avoid most of the processed products and avoid all types of added sugar.